Okay, so hello, we start the lesson. I think if I remember correctly, I wrote this example, but we didn't solve that problem if I am right. Yes, is that right?
Yes.
Okay, now let us go to the solution. So this is a rectangular cube. With these vertices, we're supposed to show two vector equalities, vector identities. One of them, number one, we want to show that FB plus BE vector plus CD is OC. Okay, so what we can do here, number one, I start from the left hand side because I want to show an equality. So one way is to start from the left hand side, continue, reach to the right hand side. So the left hand side is equal to. Of course, if I can use the Charles rule, it's better to use it, otherwise I have to look at the picture. Okay, for example, for the first pair, I don't need to. So you know that it is associative, so it doesn't matter how I prioritize these two additions, so I prioritize this in that way. But I really don't need to look at the picture at all because this is exactly the Charles rule, so those things will be cancelled. So what I'm left with is FE plus CD. But here I cannot use the Charles rule because I do not have that property here, so I have to refer to the picture. So FE is this vector from here to here, and then CD is this vector from here to here. And I want to add them up, okay? And I want to show that the result is OC. So what is your suggestion? Yes?
I mean, FB and CD.
Yes?
I mean, you can say that CD is the negative of FB.
CD is negative of FB, yes?
Yes. So they cancel each other, which gives the OC.
But that's FE.
Oh yeah, in this, yeah, I thought about another way to solve this.
Okay, but now, can you continue with this now, that I have?
Okay, FE.
Anyone else? FE plus CD, we want to convince ourselves that this is equal to OC. Yes?
If you parallel transfer CD, I mean, CD is the same as EX.
Okay, let me wait. Yes, thank you. So this becomes FE. Instead of CD, I hope that everyone agrees that I can put EX. Why is that? Because first of all, this is a rectangular cube, so we know from the properties of a rectangular cube that these two lines are parallel and of the same size. Yes? And of course, if you see CD is pointing in this direction, EX is also pointing in the same direction. So CD is exactly equal to EX, so I can remove CD and put EX, and then I will have another Charles rule, yes? Because now E and E are cancelled, so I am left with FX. But is Fx equal to OC? Yes, Fx is this vector, OC is that vector. Again, according to the properties, they are parallel, of the same size, pointing to the same direction. So there is no difference between Fx and OC. So this becomes OC, and this is equal to the right-hand side. Yes? Okay, so that's correct. Number two. So how can I convince myself that if I add this vector OA, and this vector OB, this is also a good thing to remember in a rectangular cube. So what I am doing, assume that this is your vector OA, this is vector OB, and this one is vector OC. I am adding them up, it becomes the vector OX from this corner to that corner. So it becomes the diagonal of this rectangular cube. We want to convince ourselves that this is true. So why is that? So I start from the left-hand side again. So how can I do that? So let me just draw OX. We want to make sure that this is this vector. We want to show that the sum of these three blue vectors is this green vector. Of course, this picture is not a very nice one, but if you want to imagine, that's the way that you have to imagine. So why is that?
Because adding OC and OB makes it first go to OE, and then adding OA makes it go up.
Okay, but why OB, yes, that's correct. But why OB and OC add to OE? We haven't talked about that yet. That's the parallelogram law, yes? But why is that true? You can write it in this way. So you can start from OA if you want to. So what you are talking is that let us keep OA as it is. Let me write OB, and instead of OC, I can put BE. So this is somehow what you mean, if I'm right, yes? So I repeated the first two terms, and instead of OC, I am writing BE, agree? Is that understandable? But then these two becomes the Schall rule, so what happens, it becomes OA plus OE. Yes? So now I am left with OA and OE. Okay? So what can I do? So OE is this vector. But instead of, for example, OA, I can put EX. Yes? So instead of OA, I put EX. And then I repeat OE. But I can interchange them, so that was the point in that test that you said might be. So this is in this way, it's not the Schall's rule, but I can write it as OE plus EX because I have commutativity. And then I can just drop this and then I get OX. Yes? So these kind of calculations are simple, but it is extremely important to be quick and fast in this way of calculating things. Yes? Is that understandable? Any questions? Okay. And now let me, so from now on, if I have more than two vectors and I want to add them, the best way to add them is just, for example, what do you do? So these are very simple things I want to make sure that you know. For example, if this is vector A, and I don't know, this is vector B, and then this is vector C, for example, and then this is vector D. If I want to add all these vectors, what I do, I just parallel transport this from the tip of that vector, for example. I don't want to be very good in picturing these things, but you understand what I mean. So I will take this one and parallel transport it here. Then I will take this one and parallel transport it here, yes? So then this becomes something like that. Then I will take this and parallel transport it here. It's probably not a very good picture, but then I will take the first point and connect it to the last point, and I put the tip of the arrow there. So that would be the sum of all these vectors simultaneously, yes? So this is something very easy, but you need to know. And of course, now let us go to the parallelogram law. Probably you have seen that mostly in physics. So what happens if I have two vectors? So here, the usual way of adding vectors is that you need to start the second vector from the final point of the first vector. But what happens if I have two vectors that are, for example, like this, A and B? So this is usually happens in physics, yes? For example, you have a box on a surface, and then you have, I don't know, you are pulling it in this direction, and then someone else is pulling this in this direction. So these are the forces you want to see the resultant force, what is the magnitude and in which direction it's acting, yes? So usually in physics, we have, the subject is the object that we are studying, so it means that the forces are acting at the same point. So usually in physics, vectors are starting from the same point, yes? So it is good to develop a parallelogram law here. So if I give you these two vectors in this way, and I ask you to add them, what can you do? Yes?
You parallel transport A and B.
Yeah, you can, as usual. If I want to add A to B, what I need to do, I parallel transport this and from tip of this one, yes? And then I can call this one again B. And then this vector would be A plus B, agree? Yes? But now look at here. What happens if I connect this one and this one? What would be the name of this quadrilateral?
Parallelogram.
This is parallelogram. Why?
Because the sides are parallel.
We don't know.
Those two and those two.
No, we don't know this is parallel to this one. So what I did, I parallel transport this here and draw this one and just connect these two together. But you are right, they are parallel. Why? There is a reason. I didn't draw this parallel. I just connected these 2 points together. I'm claiming that it becomes parallel. And if it is parallel, then it is a parallelogram. Because not only these are parallel, these are also parallel. But there is some, I mean, you need to be very precise if you want to talk about these things. So why is this parallel? Why this one is parallel to this one? Yes?
Because drawing that is the same as drawing A from B.
It's not the same. Yes?
Well, the lines.
No, there is something that I talked about. Do you remember? Last time, the first thing that I started with is that, what is the definition of parallelogram? You want to say something, Kevin?
I changed my mind.
Okay. So what was the definition of the parallelogram? A quadrilateral whose opposite sides are parallel. But do you remember last time I started with a theorem for you? I told you that if I give you a quadrilateral, these two sides are parallel and simultaneously equal, then we were able to prove using parallel and transversal theorem that this becomes a parallelogram. Yes? So now when I move this, when I parallel transport it here, it is not only equal in size but parallel. So this quadrilateral, according to the one that I proved last time, is a parallelogram. Yes? So from now on, that is up to you. If you have two vectors starting from the same point, one way of finding the sum of these two vectors is to complete the parallelogram that is constructed on this. What do I mean by that? I mean I go from here and I actually draw a parallel line to this, and from the tip of this one I draw a line parallel to this. So this is definitely a parallelogram because this is parallel to this according to my construction. This is also parallel to this. So, and then I will take this diagonal. This diagonal is the sum of A and B. Okay? Of course, I myself always prefer to use this triangular rule, but it doesn't mean that I don't understand or don't know this. This is also important to know. So if you have a parallelogram, this will have a very nice consequences to have this picture in mind. If you have a parallelogram, so if I have two vectors starting from the same point, then I complete the parallelogram and this diagonal would be the sum of these two vectors. Is that understandable? But the bad point about the parallelogram law is that if I want to add three vectors together, then I will be in trouble. Why? Because first of all, I need to start two of them from the same point and find the answer, and then parallel transport the other one and put it from the tip of this one and then do the parallelogram once more and then find the sum. But you see that here, I really didn't need to care. I just draw one after the other, and when it is finished, I connect the first point to the final point and I am done. Here I have to suffer more. But it is good to remember this picture because it would be important later. Is that clear? Okay. So this parallelogram law only works if these two are not parallel. If they are parallel, we cannot construct a parallelogram. But this rule, this definition, also works if they are parallel. Yes? These are very simple things. I know might be it's a little boring, but it becomes very soon interesting. Especially this week, we will face many problems. And I am designing some questions so that I will upload after we reach to some point. Yes, and then you have to start on those problems as well, and then we can discuss them in our lessons. Okay. Now, so if you remember the logic, what we did, we actually started. We are setting up algebra of vectors. So we define the vectors, we define the operation of addition of the vectors. So what is the next natural step to take? Yeah, if it is like numbers, the next thing comes to mind is subtraction. Yes, but if you are a mathematician, how define the subtraction of two vectors? If you want to keep everything similar to numbers. Yes, Dennis?
You can add the negative.
Yes, so a minus b, even in numbers, is equal to a plus the negative of b. And that is the same idea that we want to follow in vectors. So I want you to understand that if you want to really construct a mathematical structure, this is not the case that we throw everything away. Yes, we want to build up the concepts based on what we have already learned. Yes, so that's very nice. So that is, then we take this for the definition of the vectors. So let me write here definition. I want to keep it short. So let A and B be vectors, okay? And then I define A minus B. Then I put semicolon equals, means equal to by definition. A plus minus B. This is the most natural way of defining subtraction. That is exactly the same that we do it with numbers. And now we don't have any troubles. Why? Because we already know what is the meaning of B, and we already know how to add two arrows. So if I give the arrow for B, you know how to find minus B, and then you are ending up with an arrow and another arrow, you add two arrows according to the rule of addition. And that's up to you if you really want to use parallelogram way of adding or the usual way of adding. Yes? For example, if I give you this vector here, A, and if I give you this vector here, B, and if I ask you to draw A minus B, what should I do? Okay? What should I do? First of, yes, you can say.
And the vector B, you make it to the opposite direction.
So I will take this exactly parallel to itself with the same length but pointing in the opposite direction. That would be minus B. And where is it better to draw it from? It's better to draw it from the tip of this vector. Of course, I can draw it from here. If I draw it from here, I have to use the parallelogram law to add them. But if I draw it from here, it would be easier. So I will parallel transport this here somewhere, yes? And then I would put the tip of the arrow here. This would be minus B. Of course, yeah, I'm trying to draw it parallel. And then what I do, I forget about the names. I have two arrows added together and they are in the right combination. So what I do, I take the initial point and the final point. I connect them, but I need to put the tip of the arrow there. According to this definition, I am adding this arrow to this arrow, which is this one, but the definition tells me that this is A minus B. Yes? Is that understandable? So that is the vector A minus B. Okay. But another way, especially in physics, is good to know this one as well. So I am claiming that if I have two vectors, so let me draw them from the first point. So this is vector, let me call it B, and then let me call this one vector A. Okay, I draw them in this way, which is usually important in physics, and then I ask you to draw a vector which is A minus, representing A minus B. So how should I do that? Of course, that's not a big problem. I need to find minus B first and add it to A. Okay, so let us see what happens. If I want to find minus B, what can I do? I can draw this vector, if you agree with me. Yes? So the same size, but the opposite direction and along the same line. So do you agree that more or less if I had drawn it precisely, this is minus B? Okay, now I want to add this black arrow to this blue arrow in this setup. Which setup is suitable? Which one is suitable for here? Parallelogram or the usual law? Yes? Parallelogram, yes, because they have been drawn from the same point. So what should I do? I need to complete the parallelogram constructed on these two lines. So it means that from the end of this vector, I just draw a line parallel to the blue line. And from the end of the blue line, I draw a parallel line to the black line. And when they intersect, I draw this diagonal. Which diagonal? This one or that one? The first one or the second one? Yes?
From the initial point to
this one, according to that rule. So this becomes the sum. This green one is the sum of the black one and the blue one. But because the blue one is minus B, this is nothing except A minus B. Yes? Is that understandable? This is one way. But I want to give you a better idea. Instead of going through this process, which is a little bit boring, I can immediately do one thing. Can you tell me, instead of going to the left, I can immediately draw it without suffering so much. So what is that vector? Yes?
If you transport A to the below and to the tip of
Yeah,
B,
yeah.
it will be as if you.
No, no, my question is that. So of course this is completely correct, there's not something wrong with it, but I'm telling you that I really don't need to do that. If I give you the black arrows in this way, they are starting from the same point, what can I do to draw this green vector? Yes, you okay?
From B to A.
Yes, we just connect the tip of the arrows, yes? So I connect this tip to that tip, but this is important. I need to remember that I have to put the tip of the arrow pointing to the positive vector, not to the negative vector. Yes, not the other way around. So this vector is A minus B. Do you agree that this vector is A minus B as well? How should I prove that? I need to convince myself that this is a parallelogram. And this is easy to do, yes? Is it, by the way?
Yeah.
Yes, why? Because this was a parallelogram, yes? So this means that this side is parallel to this side, and its size is equal to this, and this one is equal to that, so this one is equal to this and parallel to this. Again, this is a quadrilateral, which is a parallelogram. So if this is A minus B, this is also A minus B. Okay? So remember from now on, for subtracting vectors, might be it is easier they have been drawn from the same point. Because what you need to do, you just need to connect the endpoints, but you need to remember, it's crucial. I have two possibilities. Either I can put the tip of the arrow here or there. Which one I choose? The one which points to the positive one. Yes? Okay? Yes or no? So for example, if I give you this vector here, A, and another vector here, if I ask you to draw B minus A, what I need to do, they have started from the same point, so that is very good. I connect the final points, but where should be the tip of the arrow? Is pointing, because here B is positive, so I need to put this here. So if you ask me what is this? This is a B minus A. And another way to understand this, if I add this vector, if I add this blue vector, forget about the names. If I add this blue vector to this green vector, what would be the result? This blue vector, you should be very quick. This blue vector, and then after that this green vector. What would be the result? This would be this vector. And that is reasonable. Because if you really add A to B minus A, what do you expect to get? If they are numbers, you are expecting to get B because A and A are cancelled, so you get B. So that is, if you forget what to do, you can see it in this way. Yes? Is that understandable? So now let us go back here. So this is a picture that I want you to have in mind. Okay? So if this diagonal is A plus B, the other diagonal is A minus B. Okay? So if you have a parallelogram with vectors A and B, this diagonal is the sum of two vectors, and the other diagonal is A minus vector. This is a very important picture to have in mind, especially in applications. Is that understandable? So if you have two vectors starting from the same point, and if you complete the parallelogram constructed on those two vectors, we have two diagonals. One diagonal is the sum of the vectors, the other diagonal is the difference of two vectors. Yes? And by the way, is it always the case that the sum is longer than the difference? In this picture you see the vector A plus B is longer than the vector A minus B. But do you think this is necessarily the case always?
No.
No. For example, when it happens the other way around?
If A is rotated more.
More, yes. So this angle here is an acute angle. If that angle becomes an obtuse angle, the other scenario will happen, yes? So why is that? So let me just draw these things. So it's very good to understand these things because these are nothing actually, but they are so fundamental that you have to be very quick. Otherwise you will not follow the lesson, or you will be very, very slow in understanding these calculations. So here, if I have this my vector B, if I have this as my vector A, they have started from the same point. If I ask you to draw A plus B, what you have to do, you complete the parallelogram. Of course, you can parallel transport, but in this setup, using the parallelogram at least is good to consider. Yes, I complete this parallelogram. If I connect this point to this one, this vector is A plus B. Yes? And now if I ask you to draw vector A minus B, you connect these 2 points, and this vector is A minus B. And you see in this picture that A minus B is longer than A plus B. So don't take these things for granted. Is that understandable? Okay. So, for example, let me ask you, do you remember if I wanted to solve an equation in numbers, A plus X is equal to B. A, B, and X are numbers. If I want to find X, what can I do?
X is equal to B minus A.
Yes, just I move A to the other side. Can I do the same thing with vectors? So I just want you to learn. If something works in a context, there is no guarantee that the same thing works in another context. So you need to convince yourself, is that the case? So my question is that here, if A, B, and X are numbers, you can conclude that X is equal to B minus A. Now my question is that if I have these 3 vectors, can I conclude that even for vectors these rules work? Intuitively, you should say yes, because the algebra of vectors so far is actually going one-to-one with the algebra of numbers. So whatever consequence for the numbers we have, we should also have here. Yes?
I mean, you already told us that on the one to the side there, that B minus A, if you add A to it, it should be just B. So this seems natural.
Yes, it's natural. Yes, exactly. But I just want to pay your attention that it really needs a lot of properties that might be we don't consider usually when numbers, we take them for granted. But let me try to convince you that this is the case. So, because the only thing that we can use are the properties that we have already discussed and we are sure that they are correct. So, A plus X is equal to B. If this is the case, then I can conclude that a plus minus A added to the left-hand side is equal to minus A added to the right-hand side. So this is an immediate consequence. If you tell me that these 2 vectors are the same, so it is clear that if I add this to this, it would be equal if I add this to this. Is that right? But now, can I remove these pair of brackets and put them around the first pair? The answer is yes, because of associativity. Yes, because of associativity. So this means that I put minus A plus A, and then I put X outside. Can I write this as B plus minus A? Is that right or not? Can I write this like that because of commutativity? Because here I am interchanging. Yes? And then what is the result here? We have already discussed about that. What is this one? This is the 0 vector plus X, and then this is the definition we just today learned. It is just nothing except B minus E. But we also learned that 0 vector added to any vector is equal to the vector. So you see, this was not true if one of these commutativity or associativity is not true. So be careful. If one of those properties are taken away, this simple thing doesn't work. So you need, when you want to construct new algebra, you need to be careful and always refer to your fundamental definitions and properties. Okay? Is that understandable? Okay, but now from now on, take it for granted. You don't need to justify it all the time. You just take it and take it over. Okay? Okay, now these are also good to know. So let me also talk about this. So if you have this vector A and this vector B, we just learned that this vector is A plus B. Okay. So what is the relation between the norm of this vector and the sum of the norms in general? I don't know, have you heard about this or not? So if you have a triangle, this is not related to vectors. This is just plain geometry. Of course, you need to convince yourself about this, but let us forget about that. If you have a triangle, the sum of two sides is always longer than the other side. Of course, in ancient literature, this is called donkey theorem, because in East, donkey is a symbol for stupidity. And they say that, okay, if here is your donkey and here is the food for the donkey, even donkey knows that he or she should go straight, not this way. This is, if donkey understands that this is the shortest path, that BC is less than the sum of these two, let alone we are humans, yes? Okay, but of course, in principle, you should be able to prove this using axioms of Euclidean geometry, okay? I don't want to deviate to that, but I hope that you take this for granted. So if this is little a, the length of this is little a, little c, little b, this is always the case, that the length of one of them is always smaller than the sum of the length of the other two. It doesn't matter if that is A, if this is B, you can say it's always smaller than this one, and this one is always smaller than this one. Yes? So if you know that ABC is a triangle, you can immediately conclude that this is the case. And the important thing is the other way around as well. Do you have questions?
Yeah, I'm not sure. Isn't there a case when it's equal?
No, in a triangle, in a real triangle, no. Or in a degenerate triangle, yes. Degenerate triangle means that I sit down here and I'm so heavy that it collapses here. Yes, press it down. Yes? In that case, this happens, but that's not a triangle. Technically, you can call it a triangle, but that is the term, degenerate triangle. Yes? So, if that's not the triangle, equality cannot hold us all. It's a real triangle. No, this is a strict inequality. Yes? Is that understandable? Okay, now the other way around is also correct. If I give you three numbers so that they follow all these three conditions, then definitely you can construct a triangle whose sides are of these lengths. Yes? This is important to understand. Because, for example, can you construct a triangle so that one side is 1 centimeter, the other side is 2 centimeters, and the other side is 4 centimeters? If I ask you to draw a triangle for me whose sides are these numbers, this is not possible. Why is that? Because the third number, is it possible? No. So why not?
Because 4 is
Yeah.
bigger than 4.
Yes, 4 should be less than the sum of the other two, if that is the case. But 4 is not less than the sum of 1 and 2. So it doesn't matter how hard you try, there is no triangle with these sides. But if I ask you, can you make a triangle with these sides, 1, 2, and 2.5. Can we make a triangle with these sides? Yes, because 1 is smaller than the sum of these two, 2 is smaller than the sum of these two, and 2.5 is smaller than the size of these two. And it is not hard, by the way, to understand that. Why is that? For example, if this is possible, let me draw a line segment which is 4 centimeters. Okay? And then I want to make the next side 1 centimeter. What should I do? Because the other side should end either here or here. Let us assume that I want to start from here. the distance of that point from here should be 1 centimeter. So where can I find them? Where can I find them? I put the needle of the compass here, I open the compass so that it is 1 centimeters, and then I will draw a circle around that, yes? If I ask you, what is the distance from here to here, what's the answer? 1. What is the distance from here to here? So all the distances are 1. Are there other points whose distances from this point is equal to 1? Are there other? No. So these are the only ones. And the same strategy I will do here. So I put the needle of the compass here, I open it 2 centimeters and draw another circle. Yes? So if I do that, it becomes a little bit bigger. So if I ask you what are the distances, you again say 2 centimeters. Are there other points with this property? No. But because this length is 1, this length is 2, and this distance is 4, they will not intersect. If they don't intersect, it means that I cannot find a point which is of distance 1 from here, distance 2 from here simultaneously. And if this is not working, I cannot construct this triangle. Is that understandable? But if the third one is 2.5, what happens? These two will intersect if I draw them, because this is smaller than the sum. Yes? And then when they intersect, I find the intersection point and connect it to here and there, and then I am done. That is more or less understandable why this is not the case. So if you have a triangle, this should be satisfied. And if all of them are satisfied, so I need to put an and here between them. Okay? And if all of them are satisfied, then I can construct a triangle with those lengths. Yes? Okay, now let me ask you a question. What do you think what will happen between the size of A and B minus C, or C minus B? So we learned that each side is less than the sum of the other two sides. Now my question is that how one side is related to the difference of the other two sides. Can we say something for sure or not? Yes?
Useful. You change the sign, because then if it's B minus C, then you can move C to A. So A plus C equals B.
Okay, first tell me what, and then argue that. So what is the? So my question is that, because you know that there is no difference between B plus C and C plus A, but there is a difference between B minus C and C minus A, C minus B. My question is that how this number and this number are related to A. Of course, if they are equal, it's clear the difference is 0, so A is greater than the difference. Okay? And if one of them is negative, again, this is a silly question, because this is positive, the other one is negative. So let me assume that B is greater than C. Okay? If B is greater than C, definitely A is greater than C minus B. Do you agree? Because if B is greater than C, C minus B is a negative number, so this is a positive number, so that is for sure. But if B is greater than C, B minus C is a positive number. A itself is also a positive number. Is there any guarantee that A is greater than that positive number, or smaller than that, or it depends on the situation?
Yeah, there's a guarantee.
There is a guarantee that
A is larger.
A is larger than the difference, and you are right. And the answer is clear. Why? Because I just told you that B is less than A plus C, so I move C to the left, B minus C is less than A. Finished. So it means A is greater than B minus C. Is that understandable? So you see, consider this one and bring C to the left. It becomes B minus C is less than A. It means A is greater than B minus C. Yes? Is that right or not? Okay. So it means that in any triangle, that each side is smaller than the sum of the other two, but it is larger than the difference of the other two. Is that understandable? Okay. So that is a very, very important result, and that is called triangle inequality that I want to write them. So these are triangle inequalities, but you can say that here, for example, A is always less than B plus C, and it is always greater than b minus c or c minus b, even absolute value. So we can have these relations. So that's very important to remember, these inequalities, they are very important. Yes? So if I have a triangle, I have these properties. These inequalities hold in a triangle. Yes? And if I want to do it in vectors, we can also write something like that. Because here, if I ask you what is the length here, what is the length? This is exactly the length at B. So the length here is norm of A. The length here is norm of B. Do you agree? Yes? And now, if I ask you what is the length here, it's norm of A plus B. So it is clear that the norm of A plus B is smaller than the norm of A plus norm of B. Are you following or not?
Yes.
This is the immediate consequence of what we said here on the right hand side. So each side, the length of each side is smaller than the sum of the other side. So that's the meaning. Yes or no?
Yes.
Okay. And then what can I write about this one? Absolute value of the norm of A minus norm of B. Is that also understandable? Yes? So one side is smaller than the sum of the other sides. It is larger than the difference of those sides. Yes?
Can't it be equal?
Yes, I will come back to that. Yes? But now let me improve it. What can you say about this A minus B then? Let me write it here. Can I say that this is still smaller than this? You see, these questions are simple, but it might be a little bit confusing.
Yes.
Yes, why?
Because well, I'm just picturing it.
Exactly, because the other one was A minus B, and that's also a triangle. Who cares, yes? That's another triangle, but that's a triangle. So what I do, I will draw the other one. Do you remember I told you that it's a famous picture to have in mind? This green one is A minus B. So if I ask you what is the length of this green one, you will tell me this is the norm of A minus B, agree? And that is the same story. This length is less than the sum of these two lengths. So that is also, so both this is true and this is true. So instead of writing it two times, I can just write plus and minus. So this norm is smaller than that one. And the same story goes for there. So this is the most famous triangle inequality that you need to remember, or at least be familiar with. But as Jonathan said, I want to improve it here and here, which this cannot happen in normal geometry, but in vectors it happens. Yes?
I have a question.
Yes?
Why is it absolute on the left-hand side? Or you draw two extra...
Because these are two numbers, yes? If I subtract them, it might be negative. If I say that a positive number is greater than a negative number, I didn't do a great job. I'm just telling you that even if you take absolute value and it becomes positive, still this is greater than that one. Because for the negative one, it was clear. One of them is positive, the other one is negative. Okay? So I'm just actually making it stronger. It doesn't mean that if I take it here, this is wrong. It is also correct, but sometimes it seems funny. Because if this is negative, nobody cares about understanding it. It's already done. But I am putting it, I am telling you that even if you make it positive, it will not be greater than that one. It's still smaller than that one. And now I am just putting something which was not there for the normal triangles, but for vectors we have them. And now we know why this is the case, yes? Because for example, you can convince yourself of these two vectors. If I have this vector, and let me draw this vector from the tip of that one. This is A, this is B. And if I ask you what is A plus B, Do you agree that this would be a plus b? And in this case, if I ask you what is the relation between the norm of this vector and the norms of these two vectors, you would say that this norm is equal to this norm plus that norm. So in vectors, equality can also happen. And then it is very clear when it happens, when they are parallel. Okay? And pointing to the same direction. Is it right? Yes or no?
Yes.
Okay. So this is something that's good to know here. Okay, let me ask you let me tell you something that's also good to know. Sometimes, if I give you a vector, AB, you need to bring in a new point to decompose this into two vectors. Okay? You can write it in this way. You can bring in point x and write xb minus xa. Extremely important. Okay? So, if a, b, and x are arbitrary points in a space, then this is always true. AB is xb minus xa. You can understand it in two ways. For example, let me just draw let me just consider 3 points. This is, I don't know, this is x, this is a, this is b. Yes? What is xb? xb is this vector. What is xa? xa is this vector. So forget about the names. I have two arrows started from the same point. I am interested in the difference between xb and xa. So what is that? How should I draw this vector xb minus xa? Yes? How should I do that? Quickly. Yes?
You can just
Connect the points, the final points. I connect the final points. Where should be the tip of the arrow on these final points?
speak toward the positive.
Positive one, which in this case is xb. So I have to put it here. And now read the name of this vector. What is that? It's AB, and that's the left hand side. So I just want to tell you that this is very, very simple, but very important. So I decompose this vector I write this vector as a difference. And that's the difference of, I bring in a new point, whatever I like, and then I write that new point with the final point minus that new point and the initial point. It's extremely important. Yes?
Can't you prove it algebraically?
Yes? We can prove it algebraically as well. Yes? Because I can start from the right hand side, and that's actually the shall rule in disguised form. Yes? So what can I write? It becomes xb, and then it becomes plus, what should I write? ax. And then because of commutativity, I write ax first and then xb, and then what happens? These are cancelled, so I am left with a and b. That's the same shall rule actually, but written using the subtraction things. Yes? But that's extremely important. The idea is important. Okay, now let me... This is a very simple but very important fact. I will use it later. So if I give you three vectors, so let us consider that A, B, and C are three vectors, non-zero. All of them, none of them is the zero vector. All of them are non-zero, and they are mutually non-parallel. So A is not parallel to B, A is not parallel to C, B is not parallel to zero. So none of them is parallel. So mutually non-parallel. And one more thing. I know the sum is zero. Is the zero vector. Okay? So what do you think I can conclude? Of course, might be this question might conclude a lot of things, but my point is we can conclude that I can construct a triangle with these vectors. Because that is not trivial, by the way. If I give you any three numbers, there is no guarantee that I can construct a triangle using those three numbers. Yes? You remember I just gave you an example. But I am telling you that if the sum of three vectors is equal to 0, they adjust their sizes in a way that they make a triangle, definitely. Do you understand what is the non-trivial part? Yes? I'm giving you one information. I give you 3 vectors. They are not parallel. They are not 0. But I know one more thing. I know that they add to 0. I'm claiming that if you look at the size of these 3 vectors, using those numbers, I definitely can construct a triangle. Yes?
I think
Yes?
that all of them are the same size. Or
No.
No.
they could be. Because then
No, they could be is different from they have to. Here, if you say it could be, it means that might be sometimes this is true, sometimes false. But I just try to say that it's always true. Yes.
I think one relation is 2 of them added to each other is equal to the third one.
No, it's smaller.
Then
Yeah, it's opposite.
Now, first of all, let me tell you, is the question clear? The question is that if you give me 3 vectors whose sum, if they are forces, this is very interesting. If they are forces and add up to 0, it means that taking those forces, you can construct a triangle, which is not trivial. So if I just randomly draw 3 vectors for you, there is no guarantee that they make a triangle. But here, I am telling you that because of just one simple condition, it is guaranteed that they make a triangle.
Ja, det är inte lika lätt. Eller? Ja.
Alltså den tredje
Well, I think what Dino was trying to say is that the vector A plus the vector B is equal to negative.
Yes, that is correct.
That was
Okay,
what he was
if that's
trying to
so
say.
sorry if that's the case. So let us just do that. So if you're saying minus, if you said minus,
It's opposite.
okay. So sorry, that's correct. Yes, A plus B plus C is equal to 0. We just learned that we can move this vector to the other side by making it negative. The algebra is the same. So it becomes A plus B is equal to negative C. Agree? Okay, then continue from now. So then what? Then the norm of this vector is equal to the norm of this vector. Agree? If 2 vectors are the same, the length of this one and the length of that one is the same. But what can I write for the length of minus C? It's exactly the same as the length of C itself. So if you don't mind, let me just write it another time. So this becomes the length of C itself. Yes or no?
Yeah.
Okay. And then if you don't mind, let me write it the other way around. So the length of C is equal to the length of A plus B. Yes? But then we just learned that the length of A plus B is smaller than the sum of these 2 lengths. Yes? So this means that this is smaller than the length of A plus the length of B. Am I allowed to put equality in this side? No, because they are not parallel. So what does it mean? It means that the length of one vector is smaller than the length of the other 2. Yes or no?
Yes.
Okay? Because of triangle inequality. And then I can do the same thing by moving B to the left hand side and repeat the process. I can move A to the right hand side and repeat the process. So what happens? It means that these three numbers, each one of them is smaller than the sum of the other 2, so I can make a triangle out of them. Yes or no? Yes? So that is the way. So if I want to make that I can make a triangle with 3 numbers, I have to show each one of them is smaller than the sum of the other 2. But I did it in this way, using this triangle inequality. Yes or no?
Yes.
Okay, so we are done. So from now on, if I ask you to show that some lines make a triangle, one way to do this, assume that they are vectors and show that the sum is equal to the 0 vector. Yes? This is important. We will come back to see how this might help us, okay? Okay, so now let me see if I have done everything here. Okay, so The order of numbering impression is different, so let me just not get confused. That I have done everything right here. Ah, okay. Something that I want to talk about is a little bit confusing is the angle between two vectors. I have seen even university students sometimes make mistakes in the angle. So let me call, first of all, what is if I have two lines, not vectors, and they are intersecting, let me call this one alpha. If this is alpha, this is alpha. If this is beta, this is beta. Which one we say is the angle between the vectors, between the lines? There is a convention, so this is the definition, this smaller one. Okay? So if I ask you, for example, if this is 30 and this is 150 degrees, if I ask you what is the angle between these two lines, you shouldn't say 150, you should say 30 based on this convention and definition. Yes? But now I want to talk about vectors. So if I ask you what is the angle between two vectors, so if I draw a vector here, A, and if I draw another vector here, B, if I ask you, I give you a protractor and a ruler and I ask you to find the angle between these two vectors. By definition, you have to start them from the same point. Okay, be careful. So it means that what I do, I parallel transport one of them, not from the tip of the other one, from the initial point. Be careful about this. So I will take this vector and put it here. So this would be more or less this vector. This would be, yes? And then I will take the smaller angle to be the angle between these two vectors. I have to measure this angle. This angle, by definition, is called the angle between two vectors. Yes? Now, if I want to test your understanding, what is the minimum possible value for the angle between two vectors?
90.
The minimum possible. So why do you hesitate? Yes. What is that? 0, yes? Because if I have two parallel vectors, I put them, it makes 0. And what is the largest possible value for the angle between two vectors? Pardon?
90.
No, we can have more than 90.
I mean, if it's 360, they're parallel again.
Okay, so
So
just answer my question, yes? You are answering it very smartly, okay? Just answer it. What is the maximum value that the angle between two vectors can have? Yes?
180.
180. That was your idea, but the answer is simple, 180. Why? Because, so you see, if I have this scenario, if I ask you what is the angle between these two vectors, it's 0. Okay? And if I have this scenario, if I ask you what is the angle between these two vectors, it's 180. I cannot make it bigger. Because if I go further, then this is suddenly the angle. Because I have to choose the smaller one. Is that understandable? So, yeah. So it means that the angle between two vectors, it starts from 0, at most becomes 180 depending to the situation. What is then 90 was there, Jonathan. So what is the maximum size of the angle between two lines? Is 90. Yes? Is that right? So it's a big difference. So I can have two vectors whose angle between them is 120 degrees, but I cannot have two lines whose angle between them is 120 degrees. Because if this is the case, I will say the angle is 60, not 120. Is that understandable? Yes or no?
Yes.
Okay. Now let me ask you one question. I draw this vector here, A, and I draw this vector here, B, and I give you this angle 150, and I ask you a very silly question. What is the angle between two vectors?
30.
Pardon?
30.
30. Is that clear? So I was just trying to fool you, but you didn't actually answer me, so you actually disappointed me. That's good. If I do this, it is not 150. Why? It is 30, because I told you that for having the angle between two vectors, by definition, you have to start them from the same point. Not just take your protractor and measure whatever you like. You have to do this. And actually, it doesn't matter. If you want to draw this from here, then this would be your angle. Or if you want to draw it from here, this would be your angle. But it doesn't matter. In any case, it is 30 degrees. Is that understandable? Okay. Now, what do you think here? What is the angle between two vectors?
105.
Ruben?
105.
You?
75.
You?
105.
105? 105? No one else?
Yeah, 37.5.
37.5. No, it is 105. So why is that? Because I told you, you have to draw them from the same point. One way of drawing them from the same point is to continue this guy and continue this guy. Now they are drawn from the same point, so it is the same angle. Or if you don't want, you can just draw this from here. If this is 105, this is also 105. Yes? Yes or no? Okay. So be careful. This is extremely important that you have this. Okay, let me ask you one question. I have two vectors. I give you one piece of information and I ask you about the angle between these two vectors, okay? So, I have two vectors A and B. They are not the zero vector. And I know that the norm of A plus B is equal to the norm of A minus B. Now I am asking you, by the way, this symbol sometimes be used to denote the angle between two vectors. Okay? So my question is that what is the angle between these two vectors? And why? If you have an answer for that. Yes?
It's 90.
It's 90. Someone else can say why? If someone tells you that the norm of A plus B is equal to the norm of A minus B, the angle between A and B has to be 90 degrees. This is very important results. Someone else can? The 90 is correct. Why?
Because it's a rectangle.
It's a rectangle. So I told you, remember that picture, yes? Because what happens? Do you remember this picture? I told you, this is so extreme. So let me just draw it very big so that it goes to your memory, okay? I don't know if this is bigger. It's not. So this is a rectangle. So here is A plus B, yes? And then this other diagonal is A minus B. Agree or not? Okay? So if I have two vectors, I have this scenario. But now you are giving me another piece of information. What you are telling me that the length of this diagonal is equal to the length of that diagonal. So what does it mean? It means this is not only a parallelogram, but we can say something more. It's a parallelogram whose diagonals are of the equal length. So that parallelogram is indeed a rectangle. And if this is a rectangle, it means that this angle should be 90 degrees. Is that understandable? Okay, good. Let me ask you another question, but of course this isn't probably hard. If I tell you that vector A is perpendicular to vector B, by the way, when they are perpendicular, it's clear, the angle should be 90. If this is the case, this is the symbol we use for perpendicularity, okay? And then if A is perpendicular to B, and if I tell you that the norm of A is 3 units and the norm of B is 4 units, now I ask you what is the norm of A minus B, in principle you should be able to answer that.
5.
It's 5. Yes? Yes or no?
Yes.
Because now if this is perpendicular, it means that I'm facing a rectangle, yes? This is A, 3 units, this is B, 4 units. and then I am interested in calculating the length of this one. That's just the normal Pythagoras theorem, yes? This is 3 units, this is 4 units, this is vector A minus B. I am interested in its length. So this should be just a Pythagoras theorem and I get 5. Yes, understandable? So yeah. Now, more or less these are done. Okay, let me ask you one more question. I think this example is also good. Let me ask you this question.
Happy to serve you, Barak.
Yes?
I will take that letter.
No problem. So here, let me ask you this question. We have 2 vectors. We know this, that norm of vector A is equal to norm of vector B is equal to the norm of vector A plus B. So I have 2 vectors with these properties. Now I am asking you, what is the angle between A plus B and A minus B? What is the angle? I'm not asking about the angle between A and B. I'm asking about the angle between A plus B and A minus B. I am interested in knowing this angle. Of course, if you want, you can also answer this. That you can answer 2 questions. What is the angle between A and B? Which one is easier for you? You can start with that one. Yes?
I think it's 60.
No? Angle between A and B is not 60. What you did in your brain is correct, but your conclusion is wrong. Yes, Jonathan?
It's 180.
No? Yes?
Well, I thought
Which
for
one
the
do you want
first
to
one-
answer?
For the first one, it should, isn't it 180?
No.
For the angle between.
A plus B and A minus B? No.
Yeah. Huh?
No?
Men det finns bara en punkt. De kanske är en
Because it cannot be 0, yes? If you have 2 vectors, okay, if the vectors are non-zero, I forgot. Can A be 0, by the way?
Well, then everything
No, yes, I should be careful. A and B are not 0 vectors. Of course, you're also thinking in the same way. A and B are non-zero vectors. But you said the angle between A and B is 0. This cannot happen, yes? Which one do you answer? This one or that one? This one, the first one or the second one? You said 0.
The first one.
The first one, no. None of them is 0. Because, for example, this cannot be 0, because if this is 0, this means that I have 2 vectors pointing in the same direction. And if I add them, it would be longer than each one of them individually. So this cannot be the case.
Yeah, I looked at the equal sign.
Okay, but now that what is the correct answer? Your idea is right. Your what?
120.
120. Because of the definition, yes? So, can you elaborate why you're talking about this angle, yes? Why is that?
I mean, because the only possible way for this to be true is that all sides are equal in length, and that gives us a
Isosceles. And then if all of them are the same, it becomes equilateral, yes? So what you are saying is that I have 2 vectors. I know that the length of vector A and length of vector B is the same. First of all, I need to rule out what Jonathan said. Do you agree that the angle between these 2 vectors cannot be equal to 0? Why? Because if 2 vectors are 0, consider my fingers, one of them is longer than the other one. If they want to be the same, I don't know how, so let me just do it like this. This is the tip of the arrow, this is the tip of the arrow. If the angle between these 2 vectors are 0, then if I add them, what happens? This becomes exactly twice. So then the size of the new one cannot be equal to the size of each one of them individually. So I have to rule out the 0 degrees. Yes? The 0 degree cannot happen. This is important to rule it out first. So the angle between these two vectors cannot be 0 because of this idea. This means that I have two vectors, the angle is not 0, but they are of the same size. So let me just draw them whatever you like, it doesn't matter. So assume that this is vector A. I know that the angle between them is not 0, so let me just draw it here, but I need to keep the sizes the same. Okay? And now if I ask you what is A plus B, what will happen? What is A plus B? So I can construct this. Yes? I'm making it harder, but let me tell you in this way. Instead of drawing from the same point, this is vector A. I don't know the angle yet, but let me start from this tip, okay, and make it B. Okay? You see, I have two vectors with equal length. The angle is not 0. So let me take one of them A. B is somewhere else. I parallel transport it. Instead of drawing it from here, I draw it from there. And then I ask you, what is this vector? This vector is supposed to be A plus B. Yes? Is that understandable? But you are telling me that the sizes of all these vectors are equal. So this means that this triangle is an equilateral triangle. Yes? So this means that if you ask me what is this angle, I will tell you 60, 60, 60. That was your confusion first. But the angle between A and B is not 60 because they haven't been drawn from the same point. So the angle between A and B, I need to draw them from the same point. So I parallel transport it in my head. This would be the angle between two vectors. Yes? And what that angle is? Am I right?
Yeah.
Yes. So this angle here is equal to that angle there. Yes? So that's 120. Understandable or not?
The thing is,
No, I'm also...
you have drawn it wrong, I think.
I have drawn it wrong?
Yes.
Yes. Because this should be in this direction. I'm saying that something is going wrong. Yes. This I need to draw it from that direction. Thank you. Because the direction is here. I parallel transport it here. Sorry. I parallel transport it here and I draw it from this direction. And then this is this one and this. This is the angle between these two vectors. But this angle is 120 degrees. Yes? So this is very important. You see, I am not calculating anything. I am just following geometrical arguments to use the information here to calculate the angle between A and B. Is that understandable for everyone or not? Yes? Kevin, are you happy? So why not? 100%?
No, I'm on board with the explanation. But just, I had a hard time getting there.
Okay. Okay, but you can think yourself, yes? Okay, now let us go back to this one. Now that we know something, I know that the angle between A and B is 120. This is a fact now. I want now to calculate the angle between A plus B and A minus B. So, because you know that we haven't talked a lot about geometry. Geometry is actually hasn't been treated very well in high school, but it's good to go back and learn a little bit. So, can you solve the other one? Oh, we are done. Yes.
Yeah.
Oh.
10 minutes.
10 minutes over. Okay.
Oh.
So, okay, think about that and try to see why A plus B. Do you want me to give the answer, or you want to find it out? Okay. So try to review this again. I did it very quickly. Try to really convince you there is only one way if A and B are non-zero vectors. Okay? Try to convince you this is the only possible case, and after that try to answer this question. Thank you very much.